think about tools or mechanisms to protect these kind of attacks. So to describe the anatomy of injection attacks, first the user enters the data into the web application, which runs inside an execution environment. In our case, when I'm presenting our tool, we will be talking about the PHP interpreter, but we have lots of environments like Java or ASP.NET virtual machines. So we can recognize 3 layers in these attacks. First, the information is provided by the end user. Later, this information, it's not properly handled by the web application inside the web application. So it's not aware of the malicious data that has been inserted. And at last, this information is used to perform operations which are designed for this web application, but they are specially crafted to alter the functionalities. So if we want to prevent or detect these attacks, we should do that in one of all of these layers. So, but sometimes injection attacks can get a little difficult. You say, well, if I look for SQL commands inside the user input, it should work. Well, sometimes we have to encode data in order to perform an attack. For example, when tampering get parameters, which are the ones that appear in the URL bar. For example, when trying to bypass string escaping, for example, web applications make use of some pre-designed functions to escape strings. And we can also want to exploit a third-party API, which may have a binary bug. For example, a precompiled extension in PHP. But the attack vectors change, but the vulnerable targets usually remain the same. We are talking about databases or to alter a browser's output. We can also talk about HTTP header injection or environment variables alteration. We cannot elaborate a complete list about of all these attacks and threats. So which are the common programmer workarounds? Well, first, a programmer might escape or encode and filter data provided by the user, but he can also fall into some problems. For example, if a programmer uses regular expressions to check the validity of the data, maybe he could forget about case. And if he is checking for only lowercase regular expressions, we could play with the case of the characters to bypass that check. Also, some languages allowed us to inject null bytes inside strings, and so the strings with a null byte will travel all inside the web application, and maybe if the library that checked for the validity of this data was a C-coded library, it would check until it reached the null byte. So if we put our attack after the null byte, maybe we could make an attack work also, even if the web application checks and thinks it's a valid input. So up to here, we described the threats we are facing. We've seen some known for some of you, some known threats and attacks. We described the anatomy of these attacks to generalize them. So now we are going to make a brief resume of the known tools that are available to address this kind of threats. Or maybe we should check the attack. Okay, I don't know if you can see. So the exploit retrieved the administrator username and the administrator MD5 hash. So now we will try to make this work, installing a grasp version of PHP. We will stay looking at the screen because it fails very fast, because it tries to retrieve one character and it fails, so the exploit fails. We start the web server. And try to execute the exploit again. So it starts testing for each character, and when it reaches 255, which is the last ASCII character, it returns. So it failed. The only thing we've done, we installed Grasp in an existing web server with existing web applications, and without modifying the web applications, we protected them. Now we continue with our talk. So now we'll talk about known tools to address these kind of threats. Some of them are only for detecting the vulnerabilities, and some of them are trying to block and detect ongoing exploits. We have automated source code analysis tools, which need the web application source code to analyze it. So depending on the technique, we can reach different levels of accuracy, and we must do this kind of analysis before releasing the web application, of course. So when these tools are run on a web application, we have to review all the alarms and see if we are in front of a false positive or false negative alarm. We also have scanners, which are black box testing tools, and analyze a deployed application and probe for non-vulnerabilities or have a fusor. But they mainly probe for known kind of vulnerabilities. Maybe if we are analyzing a custom-made web application, it's a bit difficult to detect some very, very difficult exploit. And they also have a high rate of false positives and negatives. We also have, in the firewalls and IDS and IPS category, some tools which work with signatures or must be trained with statistics. And they can also induce false positives and negatives. They usually don't detect specially crafted attacks. They look for patterns in input to warn about a possible attack. And they, of course, are susceptible to denial of service attack as their network counterparts. As a summary, some of these tools require an exhaustive review of all the alarms they raise. And we must confirm the false positives and negatives by hand. And we don't have evidence if we have sealed our web application because we are not sure if we have detected all the possible injection flows. So once we analyze a web application with these tools, we are not sure if we have sealed our applications from attacks. So now I will introduce the classical taint mode, which most of you should know about it, or may know about it. So it is a technique designed to address the problem of sending untrusted input to sensitive operations inside an application. It was first included by, I think it was Perl, but it only tracks data entered from outside the application, and when it reaches a sensitive function, it stops it. It's used mostly in development stages. They are useful for programmers to detect lack of checks in a web application, but in order to correct the errors, we must modify the application source code. We must add checks for each time we have an alarm. We must add a check in order to clear the mark. So in the previously described anatomy, we can locate this technique, this taint mode technique, in the third layer where the attack is being executed. So some programming languages have this protection mechanism in bundle, like Perl and Ruby. We have only two values of security for one string, which are untainted or tainted. They are useful for the programmer to check for the validity of the data that he is passing to sensitive functions. For example, here we have a Perl code snippet which retrieves a parameter called user. So in this line, the user variable is tainted, but if we check against it a regular expression, this is something useless, but it serves as an example. At this line, this variable becomes untainted. So the only thing we need to add is a simple regex check. Which are the pros and cons of these techniques? Think about this query here, this SQL query, where a username enters his username, and we check for the validity of this user. With a classical taint mode, this query would be fully marked as dangerous, even if this query is a totally valid query. So if we use this to detect ongoing exploits while an application is being run, we would fall in a lot of false positives and false negatives. This is because the string is treated as a whole and we don't have granular information about the composition of the string. But we could make use of this technique while in development stages. It's a useful technique, and it could serve as like a signal to. We should have a signal that whether if we checked or not the validity of the data. So, what are we talking about when we talk about character granularity? Let's think about instrumenting the string composition to add security data for each character inside a string. So the former query would look like this, with H meaning that that character is harmless and the D meaning that character is dangerous. So if we have control over each character in a string, we could make an analysis over the string and determine whether it's dangerous or not. In this case, although it has dangerous characters, it doesn't represent a threat to our application. So comparing these approaches, we have classical taint mode, which is useful while in development stages. While used in production or runtime, they may cause a high grade of false positives and negatives. And once we checked an application with a taint mode, we must modify the application in order to address the problems that were reported. One advantage is that it's already bundled with some programming languages, and we may use it without needing to install any extra software. We can find sensitive sources or sensitive functions quickly because every time a tainted data it's passed into a sensitive